Now we come to question number 8. Show that for all real x, mod of x is not equal to mod of cos alpha. The expression x minus 1 into cos square alpha upon x square minus cos square alpha cannot lie between half of cos alpha by 2 minus sin alpha by 2 whole square and half of cos alpha by 2 plus sin alpha by 2 whole square. Okay, let's see how to solve this question.
बेसिकली इस क्वेश्चन में हमें एक इक्वेशन एक एक्सप्रेशन दिया हुआ है, हमें प्रूव करना है कि उसकी वैल्यू एक दो हमें लिमिट्स दे दी हैं कि उनके बीच में नहीं हो सकती. जब भी हमें ऐसा कोई क्वेश्चन दिया जाता है कि एक एक्सप्रेशन की हमें बताना होता है कि वैल्यू इन दोनों के बीच में लाई नहीं करती होती या निकालना होता है कि इन दोनों के बीच में वो लाई कर सकती है, वी उस एक्सप्रेशन को बेसिकली we
use inequality.
We equate it to some other variable and then we use quadratic inequality, exactly, because that is the easiest method and that is the only method in this case actually. So basically in this question we see that our expression is x minus 1 into cos square alpha divided by x square minus cos square alpha. तो इसको हम इक्वेट कर देते हैं सपोज y के इक्वल, ठीक है. और हाँ, वी आर गिवन दैट मॉड ऑफ एक्स इज नॉट इक्वल टू कॉस अल्फा का मॉड. दिस इज जस्ट इसलिए गिवन कि सच दैट इसका डिनोमिनेटर कभी जीरो नहीं हो सकता. सो दिस टर्म इज कम्प्लीटली डिफाइंड. ओके, तो इसको हमने y के इक्वेट कर दिया. तो इफ यू क्रॉस मल्टीप्लाई दिस टर्म तो बेसिकली वी गेट अ टर्म एज वाई एक्स स्क्वायर माइनस कॉस स्क्वायर अल्फा इंटू एक्स प्लस कॉस स्क्वायर अल्फा इंटू 1 माइनस वाई, that is equal to 0. This will be our expression. Okay, now we are given that this term will always be defined. Okay, we just said कि उसका denominator कभी 0 नहीं हो सकता. Since it is defined for all x greater than for all real x, therefore we know that discriminant is obviously greater than 0. So because it is destined to have roots. Since the discriminant is greater than 0, in the condition of inequalities we always come to the discriminant so that we can eliminate x and solve in terms of y, because at the end you need to realize that here we are not concerned with the values of x, we are concerned with the value of the expression as a whole, that is we are concerned with the value of only y. So our aim is to eliminate x completely from here, and the only way that can be done is coming to the discriminant thing.
Okay, and somehow we need to bring an inequality into picture.
Exactly.
So the easiest way to do that is to think of the determinant.
Exactly. So equating its determinant to be like greater than equal to 0, we get this, and therefore solving it further or just manipulating, we get 4y square minus 4y plus cos square alpha, that will be greater than equal to 0. Okay.
Yeah.
So this will be our equation number 1. Okay. So if we see this as a quadratic equation, had it been equal to 0, we could have said that y is equal to 4 plus minus root 16 minus 16 cos square alpha. By finding the roots of a quadratic equation, we know that, and that is, on simplifying, we find it is 1 plus minus sin alpha divided by 2.
We are finding the roots to find the critical values.
No, that is because we say that ax square plus bx plus c, let this be a quadratic. We often try to factorize in the form a into x minus alpha into x minus beta, because that way analysis is always easier, because we are given the inequality. So if we factorize it, we could just find it easily. Okay, so our quadratic equation, this was a quadratic equation. Since now I have the roots, therefore I can just write this in the factorized form as y minus 1 minus sin alpha divided by 2, that is one of the roots, into y minus 1 plus sin alpha divided by 2. Okay, so basically it comes from of the form x minus alpha into x minus beta greater than equal to 0. Now we know, if suppose this to be one root, this being the other, and this being my expression, so we know that if x minus alpha into x minus beta is greater than equal to 0, we know that x should lie from minus infinity to alpha union beta to infinity with closed brackets on alpha and beta. This being my first root, this being my second, so we here can say that x should belong to minus infinity to 1 minus sin alpha divided by 2 close bracket union 1 plus sin alpha divided by 2 up till plus infinity. It is very important to note that we always put an open bracket on both minus and plus infinity, and here we use the close bracket on our terms given. So you should be able to analyze when to use a close bracket and when to use the open bracket.
And
Now-
it's basically an application of the wavy curve method only.
Exactly.
Yeah,
And
yeah.
we see that if we use trigonometric formula here, we know that 1 minus sine alpha is equal to 1 minus sine alpha is equal to cos alpha by 2 minus sine alpha by 2
Yeah.
whole square. This is a trigonometric formula. And secondly, 1 plus sine alpha is equal to cos alpha by 2 plus sine alpha by 2 whole square. Now one may wonder that how did I get the point that I have to convert this that is in my root to this form? Basically, we see the question and try to manipulate our answer to the form of the question.
Right.
So from the question we see that since y belongs to these terms, y cannot lie between 1 minus sine alpha by 2 and 1 plus sine alpha by 2. That is y belonging to, just putting the equation form, cos alpha minus sine alpha divided alpha by 2 and sine alpha by 2 whole square, and cos alpha by 2 plus sine alpha by 2 whole square. By belonging to this is not possible.
Not possible.
Okay, so basically we have proved that y cannot lie between these values.
Right.
So basically keeping in mind trigonometry and all the other topics while solving in one topic, that is the specialty of competitive exams that you should know.
So in this question, we dealt with trigonometric functions, sine and cos, as well as the concepts of quadratic equation. So whenever we talk about a range of values, a minimum or maximum, we're talking about inequalities essentially. And when inequalities come into picture, we need to somehow bring an inequality into picture. So we think of the determinant, and then we try and simplify in those terms. And another thing, whenever an inequality is there and a factorized form of an equation is there, then we try to use the wavy curve method.
Exactly.
So this was question number 8.
Now we move on to question number 9. Find the values of m for which the expression 2x squared minus 5x plus 3 upon 4x minus m can take all real values for x belonging to R not equal to m by 4. Let's see how we go about this question.
Yeah, so we see that in this question, first of all, we suppose our expression that is given to be 2x square minus 5x plus 3 by 4x minus m. We suppose it to be k. Now as we are given that this equation holds true for x belongs to R, so we know that this equation, for this, first of all we convert it into a quadratic in x, that is, this gives us a form 2x square minus 4k plus 5 into x plus 3 plus mk, that is equal to 0.
And since it is given that x cannot be equal to m by 4, so k is always defined because
Exactly.
the denominator can never be
Exactly,
0.
denominator won't be 0.
These values have to be checked. Like suppose the domain was not given, the range was not given, then we need to make sure that the expression is defined for all values.
Exactly. So in this case we are given that this is defined for all x belongs to R, so we know that the discriminant is obviously greater than 0 for the given equation. Now we know that the discriminant would come out to be 4k plus 5 whole square minus 8 into 3 plus mk.
Right.
This would be greater than equal to 0. Now we know, having a look at this equation, on opening it, this is a quadratic in k, that is 16k square plus 40 minus m 8m into k plus 1 should be greater than equal to 0.
Okay.
Now consider this equation. For this equation, we know that this equation is always greater than equal to 0. So taking this to be quadratic in k, we see that for this, number 1, its a should always be greater than 0. That is 16, that we already know is greater than 0. And secondly, its discriminant should be less than equal to 0.
Right.
Exactly. So the discriminant for this equation, that would come out to be 40 minus 8m whole square minus 4 into 16 into 1. This will be less than equal to 0.
Okay.
So if we solve this equation further, we get it to be in the form 5 minus m whole square minus 1 is less than equal to 0. Solving it further, we get it to be m minus 6 into m minus 4 less than equal to 0. That is, we get m belongs to 4 to 6. That is what we had to find in the question, the values of m.
Okay, so in this question again we see that we need to deal with a range of values. So we'll think about incorporating inequalities in the question.
Exactly.
The easiest method to do that is to think of the determinant and the range of the determinant.
Exactly.
So yeah, and that was question number 9. We start question number 10 now. Find the values of m so that the inequality mod of x square plus mx plus 1 upon x square plus x plus 1 less than 3 holds for all x belonging to R.
So we look at this question. In this question, we are given that x square plus mx plus 1 divided by x square plus x plus 1, this is less than 3 and greater than minus 3. So
Right.
we take here two cases. Let case 1 be where x square plus mx plus 1 divided by x square plus x plus 1, that will be less than 3.
पर हमने less than 3 और greater than minus 3 क्यों लिया?
Because वो mod दिया हुआ है, that mod of it is less than 3, and whenever we are given a mod, we always break it in two cases, because we need to consider both the cases as we don't know the sign for the expression. So for that case, here again we take two cases, first it being less than 3 and the second it being greater than minus 3.
Okay.
So in this case, solving this equation, we get x square plus mx plus 1 minus 3 into x square plus x plus 1 divided by x square plus x plus 1. This will be less than 0. On solving
हमने 3 को left hand side में ले
exactly.
लिया.
On solving this equation, we get our expression to be minus 2x square plus m minus 3 into my x minus 2 divided by x plus half whole square plus 3 by 4 less than 0. Now we need to remove the denominator so that we can simplify our expression, and as we can see, the denominator here will always be greater than equal to 3 by 4, as this expression will always be greater than equal to 0.
Right.
As it is a square number and 3 by 4 is obviously positive.
तो हमें हमेशा डिनोमिनेटर का साइन देखना होगा. अगर वो कभी नेगेटिव होता है तो फिर इनइक्वालिटी का साइन चेंज हो जाता है.
Whenever it is an inequality, we need to, before multiplying by denominator on both sides, we need to know its sign. If it is negative, then the sign of the comparison will change, and if it is positive, it won't be effective.
Okay.
Here we see it is positive, so it won't be affected, and our expression reduces to minus 2x square plus m minus 3 into x minus 2, that is less than 0. And on further factorizing it, we find it to be 2x square minus m minus 3 into x plus 2, that is greater than 0. Now we are given that this expression is always greater than 0, and we know that f of x being an expression, if it is greater than 0, then then a should be greater than 0, that is the coefficient of x square, and also d should be less than 0. Thus we know here obviously 2 is obviously greater than 0, so we find the discriminant, that is m minus 3 whole square minus 4 into 2 into 2. This should be less than 0.
Right.
Exactly. So this gives us value m belongs to minus 1 to 7. This is the first case. Now we come to our second case. That was, if you remember, x square plus mx plus 1 by x square plus x plus 1. This is greater than minus 3. Again proceeding as the above case, similarly, we get our equation to be 4x square plus m plus 3 into x plus 4 greater than 0.
Okay.
Now again we see that this equation being greater than 0 for all values of x, therefore a greater than 0 and d is less than 0. So again just doing its d less than 0, as this is true for all x belongs to R. The discriminant we get m plus 3 whole square minus 4 into 4 into 4. This will be less than 0. Thus solving it for m, we get it m minus 5 into m plus 11. That should be less than 0. That is m belongs to minus 11 to 5. this being the second case. Now to find
Okay.
the final value of m, we need to plot these both values on the number line and we need to find the common solution.
तो हम overlapping values लेंगे.
Exactly. This being -11, -1, 5 and 7. So by the first case we have the value of m to be -1 to -7, and in the second case we have it to be -11 to 5. So we see that these being the common values, thus we see that finally m should belong to -1 to 5, this being the final answer.
So in this question we dealt with quadratic inequalities again, and जब हमें पता है कि हमें m के values की range निकालना है और m constant terms में है, तो हम ये
we
जो
try to
condition होती
remove
है,
x from
the
x
picture
expression so that we can get a quadratic in m and solve.
that is why we use the condition a should be greater than 0 and
Exactly.
discriminant should be less than 0.
So these conditions are very important. You should know in which case you have to apply which one. Although these come very intuitively, but still they should always be in the back of your mind so that you can use them wisely in the question.
And अगर confusion होता है तो you can always draw the parabola on the graph and decide.
visualize the conditions that are to be used.
Right. So that was question number 10. Moving on to question number 11. Let y is equals to under the root of 2 upon x square minus x plus 1 minus 1 upon x plus 1 minus 2x plus 1 upon x cube plus 1. Find all the real values of x for which y takes real values. That is, find the domain.
तो इस क्वेश्चन में हम लोग को y के लिए एक्सप्रेशन दिया हुआ है रूट्स के टर्म में, और हमें बताना है कि x की सारी रियल वैल्यूज y में रियल वैल्यूज लगेगा. बेसिकली हमें सारा कुछ दे दिया है क्वेश्चन में, एंड वी जस्ट वन कंडीशन इन द क्वेश्चन दैट द टर्म इज गिवन root. So we could just start with that is the thing 2 by x square minus x plus 1 minus 1 by x plus 1 minus 2x plus 1 by x cube plus 1. That should obviously be greater than or equal to 0 as this system is under the root.
तो हमें क्वेश्चन में दिया हुआ है for which y takes real values.
Exactly.
y हमें देखना पड़ेगा y अंडर रूट में है तो उसके रियल वैल्यूज तभी पॉसिबल है जब अंडर रूट के अंदर जो
Exactly. Greater than or equal to 0. Right. So okay, after coming to this, we see that 1 to 2 is a cube, 1 is linear, and 1 is a quadratic. So it seems to be much difficult one is that how to like solve and how to multiply together. If you see carefully, x cube plus 1 can actually be written as x plus 1 into 2x square minus x plus 1. Basically, x cube plus 1 is a factor of both of these. So now there should not be a problem with taking the denominator common as x cube plus 1. We can get our denominator to be 2 into x plus 1 minus x square minus x plus 1 minus 2x plus 1. So this whole term will be greater than or equal to 0.
तो ये सिंप्लीफिकेशन के स्कोप हमें खुद
Exactly. So इसके बाद हम देखते हैं कि ऊपर on simplification it gives us minus x square plus x, and secondly in the denominator we could again break it into its factors because we will be going for factorization to the greatest extent we can. So this comes to be greater than or equal to 0. So now we need to apply that Navy curve method here, as is very clear. We have a rational expression and we just need its values. So before that, we know that this term can't be factorized, and also if you notice, the b for this case will be less than 0, and a as we know is greater than 0. Therefore, x square minus x plus 1, this will be greater than 0 for all the values of x, for all x belongs to R. Thus, we could multiply both the sides of our expression by this term, and it won't make a difference as it is positive. Thus, we get minus x square, x minus x square divided by x plus 1 will be greater than or equal to 0. Or you could say x into x minus 1 by x plus 1 is less than or equal to 0.
This is important. हमने न्यूमरेटर का साइन चेंज किया, उसको -1 से मल्टीप्लाई किया, इसलिए हमारा इनइक्वालिटी भी चेंज हो रहा है, ग्रेटर देन 0 से लेस देन 0 हो रहा है. और वीवी का मेथड अप्लाई करने के लिए हमेशा x स्क्वायर का कोएफिशिएंट पॉजिटिव होना चाहिए.
That's right.
तो हाँ, दिस इज इम्पोर्टेंट इन दिस क्वेश्चन.
तो सॉल्व करने के बाद we have our rational expression as a product of linear factors. We get the critical points to be 0, 1 and -1. So to the right side of 1, we use an n number greater than 1, suppose 2, and put it in this expression. We very well know that the value will come to be positive. Thus, we put out a positive sign to this side, therefore this becomes negative, this becomes positive again, and this becomes negative. Right. Now, our expression is to be less than equal to 0. Therefore, x can take the values minus infinity to minus 1, close bracket, because of the equality that is there, union 0, close bracket to 1, close bracket again. This is actually the solution, but now there is a very important point and a very common mistake that most of you will make. If you see carefully, according to the wavy curve method, according to your wavy curve method, this is a standard solution. But if you notice, we know that the value minus 1, our expression is not defined, as minus 1 is in the denominator. Therefore, our x should belong to minus infinity to minus 1 and open bracket, union 0 to 1 in close brackets, as if with minus 1 this expression is not even defined. So we basically see that whenever the term is whenever there is equality in the expression, we use closed bracket only for the critical points that we have obtained from the numerator. The points that have been obtained for the denominator, we don't use the closed brackets for them, because at those points the expression is not really defined. So
it's always a good idea कि जो हमारे डोमेन के क्रिटिकल पॉइंट्स हैं वो हम एक बार
check the value of the expression.
एग्जैक्टली एक बार डिनोमिनेटर चेक कर ले कि अगर 0 हो रहा है तो we should not include those points at all.
Exactly. So this was the solution to the question number 11.
Now we come to question number 12. For what values of a, exactly one root of the equation 2 raised to the power a x square minus 4 raised to the power a into x minus 2 raised to the power a minus 1 is equals to 0 lies between 1 and 2. Let's see how we solve this question.
Clearly we can see we are given in the question we have to find the values of a for which one root should lie between 1 and 2. So clearly we are gonna use our standard condition, that is for one root to lie between the values k1 and k2, we know that f of k1 into f of k2 should be less than 0. This is exactly what we are going to use here.
So?
That is basically a condition of roots defined, that is on the graph. If these be the points k1 and k2, and we want that our graph should lie something like this, such that okay, here we want just one root to lie between the k1 and k2 thing. So let our graph be this way, such that this is k2 and this be beta and this be alpha beta being the roots of the equation. So by the graph and manipulation we see that at k1 and k2
signs should be opposite.
The sign of f of k1 and the sign of f of k2 will always be opposite. If it is negative for f of k2, it should be positive for f of k1.
Right.
And had a graph been opposite, that is this way, then for that case, if f of k1 was less than 0, then f of k2 would have been greater than 0.
Right.
So in both cases, the sign should be opposite. So
Okay.
this being our condition, we simply proceed. Okay, so we know that here k1 is 1 and k2 is 2. So we know that f of 1 into f of 2, this should be less than 0. So we simply proceed in that way. We know that f of 1 will be 2 to the power a minus 4 to the power a minus 2 to the power a minus 1. And next we have f of 2. And we know very clearly that that will come on to be 4 into 2 to the power a minus 2 into 4 to the power a minus 2 to the power a minus 1, and this whole expression should be less than 0.
Right. तो
So-
हमें अब एक इनइक्वालिटी मिल गई है ओनली ए के टर्म्स
We
में.
need to solve. Exactly. ये question complicated लग सकता है because a is in the exponent. But just using our standard rules and guidelines, we need to solve this question and very easily we'll get the answer. So
और क्योंकि हमें पता है कि हम एक्सपोनेंट्स के साथ हमें उतना ज़्यादा डील करना आता नहीं है, तो हमें सब्सटीट्यूट करके ट्राई करना चाहिए कि हमें क्वाड्रेटिक मिल जाए.
exactly. So either we'll just continue with this, and on simplifying it, we get minus 4 to the power a minus 1 into 3 into 2 to the power a minus 2 into 4 to the power a minus 1. This is less than 0. That is, on simplifying further, we get 1 plus 4 to the power a into 2 into 2 to the power 2a minus 3 into 2 to the power a plus 1. This term should be less than 0. So, on solving this further, we also know that 1 plus 4 to the power a will be greater than 0 for all values of a. Okay.
Right.
So, we could just divide by this term on both the sides. Thus, we get 2 into 2 to the power 2a minus 3 into 2 to the power a plus 1. This will be simply less than 0. Now, we here see that 2 to the power a, if we suppose it to be t. Okay, so in that case, we get 2t square minus 3t plus 1 is less than 0. Thus, this is a quadratic in t. That
Right.
is, exactly, on factorizing it, we get it to be t minus 1 into 2t minus 1. This will be less than 0. That is t, or we could say 2 to the power a. This should be less than 1 and greater than half. That is 2 to the power a belongs to half to 1.
बट हमें ए के रेंज ए का
Exactly, we
रेंज
need to find the values for a. So for this, we take log on both sides. Take log on both sides. We get log to the base 2 of half is less than a less than log to the base 2 1. Thus we see that minus 1 less than a less than 0, as we know that log half to the base 2 is minus 1 and log 1 is obviously 0 to any base. Thus we see that a should belong to minus 1 to 0 for the given condition, for the given equation, given equation's one root to lie between 1 and 2.
Okay, so in this question we dealt with exponential values, logs, etc etc. So basically quadratic equations के questions में करने के लिए आपके सारे concepts clear होने चाहिए maths के.
Exactly.
Even in concepts involving logarithms or modulus, all these should
Questions
be very
based
clear.
purely on quadratic would be very rare.
Very
so
rare.
basically it would involve questions from other topics as well.
Right. That was question number 12.